Normally, we're talking about books, we're talking about reading, and we're talking about lots of stuff in between. But today, I'm going to switch hats because that doctor in my name, it's not just for show. I'm a professor of elementary literacy education, and I spent nearly 2 decades studying how we learn to read. And I am in something of an algorithmic bad place. Not accidentally, but commented on a Bionic reading video, and that seems to be what the algorithm thinks we want. And here's the thing, we're surrounded by hacks like this that promise faster, better reading, speed reading, special fonts, reading while listening. But are they really helping us? Or are they just distractions from the reading that we want to do? Today, I'm going to dive into the science of reading to bust some myths and to get to the heart of what makes us confident, connected readers. Along the way, we'll talk about the brain, the books that explore it, and why understanding this process matters, whether you're picking up your next novel or helping a child to learn to read. And here's the question to keep in mind. What if those flashy hacks aren't just ineffective, they're actually taking time away from the joy and connection of reading? I'm Nick. This is Dr. Cranky Pants Reads. Stick around, we'll figure it out together. Back to my other hat. Reading is one of those skills that we often take for granted until we try to teach it or figure out why it's so hard for some kids and so easy for others. One of the biggest impediments for my undergraduate students is the fact that they are skilled readers, and it becomes really tricky for them to think about how to actually teach reading. And this is where the simple view of reading comes in to be really helpful. Developed by researchers Philip Goff and William Tunmer in 1986, the simple view of reading has become a cornerstone in understanding how we read and how to teach reading effectively. At its core, the simple view of reading boils down to this equation: word recognition multiplied by language comprehension equals reading comprehension. Word recognition is really all about decoding, the ability to figure out the words on the page based upon the letter sound relationships you know. This allows you to figure out how these words are pronounced and what they mean. Language comprehension, on the other hand, deals with how you understand these words in context, how they fit together to form sentences or syntax, paragraphs, and meaning. When these two skills work together, you get reading comprehension, the ultimate goal of reading. But, and this is key, they're not equally simple to develop. Decoding is often where we start with young readers, teaching them phonics or letter sound relationships and how to break or segment words apart. But as decoding, understanding increasingly complex ideas, building connections, and building, ultimately, knowledge. Now, knowing what reading involves is one thing, but how do we figure out the best ways to teach it? That's where research in the science of reading comes into play. And spoiler alert, not all research is going to be created equal. When we think of research, we might imagine reading a few articles, trying out a new teaching method, or even asking other parents or teachers for advice. But in a science of reading, research is something much more rigorous. Let's break it down. Here's what good research looks like. It's a carefully planned study where researchers have designed experiments where one group of students learns from a new method while the other sticks with a standard approach. This lets researchers compare the results and figure out if the new method actually works. There's also this sense of a science of reading focusing on one of 5 essential areas, or at least one of 5 essential areas. Phonemic awareness. This is typically whether or not kids can hear and manipulate the sounds in words. Phonics. Do they understand the alphabetic principle and the idea that letters represent sounds? Fluency. Are they reading smoothly and accurately? And vocabulary. How do they know what words mean? How deep is their knowledge of those words, and how wide are their vocabularies? And lastly, comprehension. Can they understand the bigger picture? And can they use that information to do work in the world? Now, we're also thinking through reliable evidence. Good research uses standardized tools, things like validated reading assessments to measure process and progress. The results aren't just guesses, they're backed by data and detailed, reproducible analysis. Okay, so why does this matter? Because when we think about research, it's easy to confuse causal relationships or causal observations with rigorous systematic studies. For example, trying out a new app with your child might feel like research, but it lacks the rigor and scope that makes science of reading studies so valuable. Here's what sets a rigorous research study apart. First off is the very notion of rigor. A science of reading research study is carefully designed to control for variables that could influence the outcome. For instance, studies use experimental methods like control groups and random assignments to isolate the effects of a teaching method. What this does is it eliminates bias and ensures that the findings are going to be trustworthy. There's also a sense of scope. Unlike personal experiments or small scale observations, these studies include hundreds or even thousands of participants from diverse backgrounds. This ensures the findings apply broadly, not just to one classroom or a single group of learners. So, rigorous research not only helps us understand what works in teaching reading, but also dives deep into why it works. One of the most fascinating things researchers have uncovered is the incredible way the brain adapts to reading, a skill we aren't born with, but have to develop. Which brings us to a big question: where in the brain does reading happen? For most of us, the process of reading is primarily going to take place in the left hemisphere. This is where critical language processing areas like the visual word form area, Wernicke's area, and Broca's area are located. These areas are going to help us decode, comprehend, and internalize the words we read. This is where critical language processing areas like the visual word form area, Wernicke's area, and Broca's area are located. These areas help us decode, comprehend, and internalize the words we read. But here's something important to know. Just because reading is mostly a left hemisphere activity doesn't mean we can chalk it up to the old left brain versus right brain myth. The idea that the left brain is logical and the right brain is creative, that's been thoroughly debunked. The truth is, we can't have a growth mindset and also restrict ourselves from using half of our brain. We as learners use our whole brain, and reading is no exception. While the left hemisphere takes the lead in processing text, the right hemisphere also plays a supporting role, helping us understand context, emotion, and nuance. And here's where it gets really fascinating. Our brains are remarkably adaptable. Research shows that if the left hemisphere is damaged due to, say, trauma, stroke, or some other factor, the right hemisphere can step in and take over some of the functions usually handled by the left. For example, studies have shown that individuals with left hemisphere damage can relearn or recover reading skills through neuroplasticity. While the right hemisphere isn't as specialized for these tasks, its ability to compensate highlights just how resilient and low-key amazing our brains really are. And this adaptability isn't just a neat fact, it's a reminder of how complex and resourceful our brains are, and it helps us see why reading isn't just about one side of the brain or the other, but rather a carefully coordinated process that involves multiple areas working together. So let's break this down just a little bit further and explore how the brain's four main lobes and some key specialized areas contribute to the act of reading. I want to keep everyone in the know. This is a brain, not a piece of broccoli. Anyway, when we think about reading, it's all going to start in the occipital lobe, which is back here. When visual processing happens, when you see a word on the page, the occipital lobe is going to help you recognize the shapes of letters and the patterns of words. That's what allows you to distinguish one letter from another and follow your line of text without losing your place. Now, next up, we're going to talk about phonological processing and decoding, and that's happening up here. This is the parietal lobe, and parietal lobe steps in to link those visual inputs to sound, a process called decoding. Think of it like turning written symbols into spoken language. This lobe connects the shapes of letters to the sounds they represent. It also helps us keep our place on the page, guiding our eyes from left to right and ensuring we don't accidentally skip a line. This is especially important for early readers who are just learning to make sense of print. Now, then we move over to the temporal lobe. Once the parietal lobe has helped decode the letters into sound, the temporal lobe, which is right here, begins to take over and make sense of it all. This is where comprehension begins. The temporal lobe doesn't just process individual words, it helps you understand sentences, follow the flow of ideas, and connect what you're reading to your prior knowledge. It's like your brain's story builder, piecing together meaning as you read. Finally, the frontal lobe steps in to do the heavy lifting. This is where higher order thinking happens, things like making connections, asking questions, and predicting what might happen next. The frontal lobe is going to integrate all of the information processed by the other lobes, allowing you to actively engage with the text and construct meaning. It's where comprehension becomes personal, as you link new ideas to your own experiences and knowledge. Now that we've covered the big picture roles of the four lobes, let's zoom in on three specialized areas that handle specific tasks in reading: the visual word form area, Wernicke's area, and Broca's area. Let's take on the visual word form area first. The visual word form area, or VWFA, is like the brain's internal dictionary, and that's typically located right around this area and the left occipital temporal region. And what it does is recognizes familiar letter patterns and connects them to sounds and meanings. In this area, for skilled readers, it works so efficiently that word recognition almost becomes automatic. This is why fluent readers don't have to sound out every word. They've built a strong VWFA that does it for them. This tends to be what we talk about with teachers as where the sight words are located. Now, Wernicke's area is deep in the temporal lobe, on almost the edge of the parietal lobe, and this is the brain's language comprehension hub. It helps us understand not just individual words, but also the meaning of sentences and paragraphs, particularly those words that need context. Wernicke's area is the space in our brain that considers the relationships between the words bolt and lightning, or bolt and fabric. In each of these examples, bolt means something different based upon its context. Lastly, Broca's area in the frontal lobe plays a critical role in reading. Traditionally associated with speech, it helps us subvocalize, or hear the words in our minds as we read. This internal narration deepens comprehension by helping us actively engage in the text. Remember this, we're going to come back to it later. It's like having an internal narrator guiding us through the story. So, as you can see, reading isn't just one skill. It's a complex process that involves multiple areas of the brain working together in harmony. These regions form what scientists call the brain's reading circuit, and it's a network that strengthens and adapts through practice across our entire lifespan. Because reading requires so much coordination, it's not really something you can hack or shortcut. But with time, persistence, and the right strategies, the brain learns to make reading feel almost effortless, one of the most rewarding skills we can develop. Because as skilled readers, we can take that process for granted until we're faced with a massive TBR pile and too little time to work through it. Enter the reading hacks. Speed reading techniques, fancy fonts, or even listening while reading that promise to make us faster, smarter, or just better readers. But what does the research say? Let's bust 3 popular reading myths with a little help from science. Let's start with the idea of speed reading. It's a tempting process. Finish a book in a day, triple your reading speed, and understand everything effortlessly. But the science behind how we read tells a very different story. Speed reading programs often claim that we're not using our full reading capacity and that by changing our habits, we can unlock untapped potential. These programs tend to rely on 3 methods: taking in more information at once, eliminating subvocalization, hopefully you remember what that is, and avoiding regressive eye movements. Let's break these down. The first claim is that you can train your eyes to process larger chunks of text, whole lines, paragraphs, or even pages, all at once. Techniques like using a finger to zigzag across the page or moving it up and down the center to scan entire lines are supposed to help with this. But here's the problem. Our visual system doesn't work that way. Research on eye movement, like those by Keith Rayner, his work is in the bibliography, shows that when we read, our eyes rely on a sequence of fixations and saccades. Fixations are those brief pauses where we process text, and saccades are the jumps in between them. The human eye can only process a limited number of letters in focus at one time, and peripheral vision doesn't add much detail. You can't force your eyes to take in more information than they're biologically designed to handle. So when speed reading programs claim you can read an entire page at a glance, they're ignoring literally the constraints of human biology. It's not just unlikely, it's impossible. The second claim is that subvocalization, that voice in your head as you read, is a bad habit slowing you down. Speed reading programs encourage exercises to suppress this, claiming it will boost your speed. But here's the truth. Subvocalization isn't just a quirk. It's an essential part of skilled reading. Subvocalization activates the phonological code, which helps your brain distinguish between words like permit and permit. This process links the sounds of words to their meanings, allowing you to fully comprehend the text. When you eliminate subvocalization, it doesn't free up your brain. It removes one of the most important tools that you have to understand what you just read. Research shows that efficient use of phonological information is a hallmark of skilled readers. The last claim is that you should eliminate regressive eye movements, those moments where your eyes go back to reread part of a sentence. Speed reading programs insist that if you get it right the first time, you don't need to look back. But regressions aren't just about fixing mistakes. They're a natural part of how skilled readers enhance understanding. Sometimes looking back helps clarify meaning, especially in the case of complex sentences where key information appears earlier or later in the text. Language, it's not always linear, and skilled readers know when to look back to build a clearer picture. Forcing yourself to avoid regressions can actually make reading harder, not easier at all. So here's the reality about speed reading. It doesn't align with how our eyes and our brains are designed to process text. Instead of improving comprehension, it disrupts the natural flow of reading. Research shows that comprehension is built incrementally, word by word, sentence by sentence, through fixations, phonological processing, and even regressions. Speed reading techniques don't just cut corners, but they often undermine the very skills that make reading possible. So instead of racing through books, give yourself permission to slow down, absorb, and truly connect with the text. It's not about how fast you read, it's about how much you take away from the experience. Now let's talk about myth number 2. You've probably seen the flashy promises, Bionic reading will guide your eyes faster, or dyslexia-friendly fonts improve comprehension for everyone. But do these tricks actually work? Bionic reading bolds the first letters of words to guide your eyes, but research has found it actually has no real benefits. Instead, the bolding can cause your eyes to fixate or stop unnecessarily, disrupting the natural rhythm of reading. Similarly, while fonts like dyslexia may help readers with specific needs, studies show that they don't improve comprehension for the general population. In fact, for fluent readers, these fonts can introduce some visual distractions, slowing reading down rather than speeding it up. Efficient reading relies on a smooth, uninterrupted flow. Techniques like bolded text or unusual fonts often add bumps to the road, making it harder for your brain to process text naturally. Now let's hit myth number 3, reading while listening. On the surface, this seems like the perfect solution. Double the input should mean double the comprehension, right? You're reading the words on the page while listening to them at the same time. But the science behind it's a little more complicated. According to a meta-analysis by Clinton Liesel, the idea that reading while listening universally enhances comprehension isn't fully supported. There are a few key reasons for this, and they come down to how our brains process information. First, let's talk about the dual channel hypothesis. Our brains can process information through both auditory and visual channels simultaneously, and theoretically, this should enhance comprehension. In controlled, experimenter-paced settings, there were small benefits, but so small that you might not notice the change in efficiency. So while it sounds good on paper, the real-world advantages of combining reading and listening are minimal. It's not the magical comprehension booster that it's claimed to be. Now let's look at cognitive load theory. This tells us that presenting the same information in two formats, visual and auditory, can lead to cognitive overload, especially when content is redundant. Essentially, your brain is trying to process the same information twice, which can actually split your attention rather than enhance it. In self-paced reading scenarios, where you control the speed of both reading and listening, this overload can actually diminish comprehension. Instead of boosting understanding, the dual inputs often create confusion or reduce the focus needed to fully grasp the materials. Now, pacing is also playing a critical role here. In experimenter-paced settings where the audio controls the flow and prevents rereading, there's slightly more support for reading while listening. But when you're in control of the pace, like most real-world reading scenarios, the dual input model breaks down. Readers often struggle to synchronize the two inputs, making comprehension harder instead of easier. This suggests that reading while listening to work, pacing has to be highly controlled, something that's just not practical for the most of us. There's one exception though: struggling readers, including students learning new languages. For individuals who find decoding words challenging, reading while listening can reduce the cognitive load demands of decoding and let them focus on comprehension. And there is also evidence that this practice helps those learning a new language grow their vocabularies. But for proficient readers, particularly with complex or detailed content, the redundancy effect outweighs any potential benefits. In these cases, it's often more effective to stick to one medium at a time, either reading or listening. I've got my references below, but if academic papers aren't your thing, don't worry. I've got you covered. These 3 books are going to break down the science of reading in an engaging and accessible way. So, let's talk about these gems. First up, I have Proust and the Squid by Maryanne Wolf. This book is a fascinating deep dive into how the brain learns to read and how reading has evolved throughout human history. Maryanne Wolf blends science with storytelling, explaining everything from the invention of written language to how different cultures approach reading. If you're curious about how your brain builds its reading circuit or want to understand why reading is such a uniquely human achievement, this one is for you. It's both thought-provoking and pretty accessible. Stanislas Dehaene is a cognitive neuroscientist, and this book, Reading in the Brain, takes you right into the brain's wiring for reading. It's packed with cutting-edge research, but Dehaene writes in a way that's surprisingly accessible. He also explains how the visual word form area, the brain's library for recognizing words, works and why reading requires such a coordinated effort from different regions of the brain. Last but not least, and this one's a little spicier, Mark Seidenberg doesn't shy away from critiquing the education system's approach to teaching reading. That's me. He combines research on how reading works with real-world implications for schools and literacy. It's a great pick if you're interested not just in the science, but also how the science translates to how we teach, and sometimes fails to teach, reading. So here's the big takeaway. Reading isn't really something we can hack. It's something we have to nurture. The science of reading gives us a roadmap, showing us how the brain learns and grows through practice and patience and persistence. Hacks like speed reading or fancy fonts often distract us from what really matters, spending time with our books and truly engaging with them. As a teacher-educator, I see how these trends can sometimes seep into classrooms, taking valuable time away from proven, evidence-based practices. That's why understanding what good research looks like is so important, not just for teachers, but for anyone who loves reading or wants to help others learn to read. So how can you be a critical consumer of research? Remember to ask, was it rigorous? Was it transparent? Did it involve a diverse group of participants? And most importantly, are the findings applicable to real-world reading experiences? By asking these questions, you can sort through the noise and focus in on what actually works, whether you're exploring new strategies for yourself or supporting a young reader. Thanks for watching and for caring about how we read and for being part of this conversation. I appreciate you and I hope life is good. In next week's video, I will be going over my favorite books I read in November. I look forward to seeing you there.